Accelerated algebra 2 stroke here. So we're going to go through 5i, simplifying radical expressions, and see how we do. Which are perfect squares? Well, this is 6 times 6, this is 10 times 10, this is 11 times 11, this is 8c times 8c. This would be a perfect square as well because it would just come out to be x. If I distribute that in, it would be x squared, y squared. This would be x to the second, y to the third if I took the square root. So there could be some other perfect squares in there that I'm just not seeing right away, so, for the most part. So let's erase this and see what you got for. So you got a radical sign.
So when you guys get paid for my...
Alright, so square root is a number r, and the square root is a number r. So if you multiply two things together, root a times root a is root a squared, which is a. So the radical sign is this symbol. We can have numbers that are up in here. So we have third roots, fourth roots, fifth roots, whatever root we want. Let's see what we have here to erase. So positive square root, and then if you do the opposite of the square root, so you get the negative out front. Okay, so this could give this one right here, your answer would be negative. It wouldn't be that you took the square root of a negative number, it was just because you have the opposite sign here. So the radicand is the number expression under the radical sign. Okay, this is all, it should be common knowledge for the most part. The radical is the entire expression. Alright, let's first perfect squares up to 625. Alright, so you have 0 because that's 0 times 0, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, 13 times 13, 14 times 14, 15 times 15, and I don't have them in my head right now. 16 times 16. 256. 17 times 17. 289. 18 times 18. 324. Hello. 19 times 19. 361. 20 times 20. 21 times 21. 22 times 22. 25 or 23 times 23. 24 times 24. 596. And then 25 times 25. So those are our first perfect squares. Alright, so let's work this first problem. So this is going to come out to root 100 if you multiply, which comes out to 10. This is also 10. We're just showing that if I multiply those together, I get root 36, which is just 6. Then we have a fraction in there, so at the top's of perfect square, bottom perfect square, you get 2 over 3. Okay, realize you can break this apart into both to the top and bottom. Same with this one. So this one would come out to be 4 over 5. You can also start separating them. Okay, you can break them apart, or if they're both in a fraction, you can break them apart as well. The radicand has no perfect square factors other than 1. There is no radical in the denominator. So this is kind of a different clue. We don't have to rationalize the denominators all the time, but we'll talk about that a little bit. Okay, so square root of 45, we're going to break that up to 9 times 5 because 9 is the biggest perfect square, which comes out to 3 root 5. This becomes 5 times 16. So I'm going to get 4 root 5 here. 700 breaks up to 7 times 100, so that's going to give me 10 root 7. 242 is the same thing, 2 times 121, so that's 11 root 2. This one's going to break up to root 11 over 10. There's no longer a square root in the bottom. And then number 6, we're going to get root 2 over root 7. In pre-calc, for the most part, you can probably leave it like that. We want you to rationalize it, and it really comes down to what long division was a long time ago. But that's what the answer is. You cannot reduce outside of a radical to inside a radical. So that's going to be root 25, which is 5. This is going to give you 8 root 9. Root 9 is 3, so I get 24 for an answer. And when you start seeing these, sometimes it's easier to start breaking them up. 6 is 2 times 3, 15 is 3 times 5. That's a perfect square, so I'd have a 3 outside. Inside I'd have the 2 and the 5, which is 10. And again, I'm going to start breaking this apart. I get 3 and 7, 35 is 7 and 5. This is a perfect square here, so I get 7 root 15. This is going to give me 15 root 36, which is going to give me 15 times 6. And that gives me 90. On this one here, that's stuck behind that, I can actually reduce the fraction. So I'm going to get root 1 over root 4. Root 1 is 1 over 2. So I can reduce the fraction if they're both underneath the radical. So the radical and the square, they undo each other, so this answer just becomes x plus 4. This one, square root of 16 is 4. Square root of this is going to give me this. So I'd say, oops, 2x minus 7. So you could leave it like that. Some people might choose to have you multiply it out. I'd say either of those answers are totally fine. If some of these are bringing up questions for you, please bring those questions to class. All right, so now we're going to start FOILing these. These actually are conjugates. Conjugate is when you have the exact same binomials, opposite of sign. So if I FOIL this out, I'd get 4. The outside and the inside cancel each other out. You'd get 2 root 3 and negative 2 root 3. They'd cancel out. And then if you multiply the last, I'm going to get negative root 9, which is 3. So my answer here is 1. This is not a conjugate. There's the exact same thing. So I'm going to get 16 minus 4 root 5 minus 4 root 5 minus root 25. Combine like terms, well, root 25 is 5, so 16 minus 5 is 11 minus 8 root 5. Number 17, if I FOIL this out again, they're not conjugates because they're the same binomial, so I'm going to get 49 plus 7 root 3 plus 7 root 3 plus root 9. Well, root 9 is 3. 3 plus that is 52 plus 14 root 3. These are conjugates, so the middle terms will cancel out, so I'm going to get 25 minus root 4. Okay, if you keep FOILing it out, you'd wind up getting 5 root 2 and negative 5 root 2. 25 minus square root of 4 is 25 minus 2, which is 23. Try these. Okay, so we'll go ahead and add underneath first. So I'm going to get 100, which gives me 10. On this one, that's going to give me root 9, which gives me 3. But this one, I can't add them together. I have to take the square root of 64 to get 8, square root of 36 to get 6, so I get 14. Square root of 25 is 5, minus square root of 16 is 4, so I get an answer of 1. These are going to be like terms because they're both root 3, so 4 plus 5 is 9, so I get 9 root 3. Notice I did not increase the radical because I'm just adding and subtracting. Same thing here. 7 minus 2 is 5, so I get 5 root 6, which I see the answers are below on both of those. On this particular one, let's break this up. That's going to be 25 times 3, which is going to give me 5 root 3. This is going to give me 25 times 2, which is going to give me 5 root 2. I cannot go any further with that because I have two different radicals. I'm going to break that into 4 and 3. Square root of 4 is 2, so I get a 6 outside, root 3. And then this is going to give me 9 and 3, so that's going to give me 3 root 3. And then I can go ahead and subtract these, so I get 3 root 3. You're good. And that's all we have, my friends. So if you have some questions, please make sure you bring those back to class. We'll talk about them and go over them. Have a great day, everybody. Take care of one another.